Good afternoon, everyone. This is the continuation of the previous case study by Muskan on Mintra's e-commerce platform recommendation using MDP reinforcement learning technique. This is another case study by Apoorva, and she wants to discuss about applying the RL fundamentals to the problem statement emotion aware music recommendation system. Okay. So, without wasting one time, I will hand over this to Apoorva so that she explains her case study using the fundamentals of reinforcement learning framework. And like I did it with Apoorva, I will try to also frame problem statements for her as well in a particular format. Just to highlight that what is RL, I will repeat. RL is an advanced machine learning technique, okay, where we used um, experience and feedback mechanism for more better optimized prediction algorithms for applications where AI and machine learning are can be applied. Okay, so her highlight is on emotion aware music recommendation system. So go ahead, Apoorva.
Okay, ma'am. So, as the problem statement mentioned already by you, which is emotion aware music recommendation system. So, basically, here a recommendation music recommendation system is being established wherein it will recommend you music according to the user's or the client's current emotion or the current emotion which he or she is feeling. So, for that, the first point is the RL framework. In RL framework, in general, we have certain terminologies, which is the set of states. A is for set of actions. P is the transition probability, and R reward functions, and the last one is discount factor. So I have applied these five terminologies to my problem statement. So wherein the set of states are the current emotions of the user's emotional states, and they are detected using the facial expression, which is the best way you can analyze and you can observe that what that user is feeling, whether the user is happy, sad, or angry. The voice tone or the interaction set of states is happy, sad, angry, excited, anxious, and etc. Then the second one is the set of actions, that is the type of songs or playlist recommended. So, for example, if I am the user and I am sad or my current emotion is equals to sad, so the system or the model uh, should recommend me some songs which are soothing or which will keep my mind in a peaceful state. So that is the set of action, the action of recommending or suggesting songs. Example: calm, energetic, chill, motivational songs if the user is sad. Then the third one is transition probability. Transition is basically a change in something. So over here, the if I am the user and I am listening and I'm sad, my current emotion is sad, and I'm listening to a peaceful song. So my emotion should transit from sad to neutral or from sad to calm. So that is what the transition probability does. The probability that the user's mood changes after hearing a certain type of song. Then we have the reward function. So if I have been recommended a song and I play it, so accordingly, if I like the song and have saved the song, it's plus 20. And if I fully played it, but I didn't like the song, it's plus 10. And if I've skipped the halfway, for example, if the song is of 3 minutes and I have just played it half the time, so it's plus 2. And if I've skipped instantly, that is the user didn't like the song at all, it's minus 5. So that is the reward. And the output should be like model will try to get the maximum value of its reward, that is plus 20. And discount factor is it balances the short term joy and the long term satisfaction. Short term joy is basically if I'm hearing the song and I feel good for just a certain while, that is short term. But if I hear a song and I feel good, energetic, and I'm into my normal zone, that's a long term satisfaction. So a high discount factor prioritizes overall user happiness over the time. So this is how I have applied these RL framework terminologies to my music recommendation, emotion aware music recommendation system. Then we have the agent environment interaction. Agent environment in our system. So the first one is observation. Observation as in the agent detects the user's current emotional state. So as it's a model, so through the past experiences or through its past learning, it will detect my emotion based on my features, facial features, tone, etc. And action selection. So for example, if it is correctly able to select my emotion, then it will choose at what type of music should be recommended to me. Then environment response, the user listens to the song, possibly changes the mood and gives the feedback. So that is the environment response. That is the response given by updates its recommendation strategy based on the feedback. So if I didn't like the song, so it will improvise its learning strategy so that the next time it should get the maximum amount of reward. Here the agent is the music recommendation model and the environment is the user's emotional state. So agent over here is the my system or the model. Environment is the emotional state, is my emotional state, and the feedback. Then this third topic or the third RL term which I have implemented here is the value functions and policies. In value functions, there are two: state value functions and action value functions. State value functions represents the expected satisfaction when the user is in the emotional state S. So if the user is an emotional state as, for example, sad, so what is the expected outcome which the model is expecting? Like obviously the user should be happy or in a neutral state after hearing the song. And the action value function is, it represents the expected satisfaction when the system recommends the song type A in mood S and then continues following it. The goal is to learn a policy that maximizes the total long term reward. So, the goal for the model is to apply that policy which will yield to maximum rewards or which will yield to a long term reward, that is, long term happiness over here. And then learning algorithm. So Q learning algorithm can be applied, or the model can apply the Q learning algorithm to learn the optimal action value function. Over here, this is the formula given for the Q learning algorithm, uh, wherein the terms over here are alpha over here is the learning rate, the rate at which the model is learning to how to analyze the emotions or the current emotions of the user and to update it accordingly. And R is the immediate reward from the user feedback, that is how much did the user liked the song or did not like the song. Discount factor, as earlier discussed, discount factor for long term satisfaction, and the estimated best possible future reward after the new state S. New state S, new current state is S and new state is S dash. So that is the estimated best possible future. For example, if the user is sad and hears a motivational song, gets happy. So over here, the current state was sad, new state is happy, and likes the song. So the reward over here is plus 20. So Q learning will increase the Q value for sad and then making it more likely to recommend motivational songs. So this is how the model will learn that okay, when the user in this XYZ emotion, I have to recommend this particular this applied the RL terminologies, framework, and etc. to my problem statement, which was emotion aware music recommendation system. Thank you.
Yes, very good, Apoorva. The problem statement, however, it looks simple. Okay, I'll just try to brief that my recommendations on it, like we did it for earlier for Muskan. If you reframe this problem statement, how do you like this? Emotion aware music recommendation using reinforcement learning, integrating user dynamics with contextual bandwidth and deep Q learning models. Does it sound good to you, Apoorva?
Yes, ma'am.
Okay. So just we'll go one step ahead that basically all the recommendation systems like Spotify or YouTube Music, they suggest songs based on the past listing, history, user ratings, and general preferences. But they don't change the recommendations in real world based on how you are feeling right now. I think this is what you're trying to say, Apoorva. So this becomes the introduction of your research paper. This becomes the research paper title. Okay. And this is how we go ahead. So in this project, you can mention that in this paper, what are you proposing? You are proposing a music recommendation. So this is the existing lacuna in the existing applications, and you are trying to recover through this research paper or project, okay, or through the recommending algorithm using RL. Okay, so it detects the current emotion from signals like facial expression, voice tone, or wearable sensors, and then it uses reinforcement learning to continuously learn which songs approve the user's mood or match it perfectly. Fine. So the system improves itself every time you give feedback. And whatever you explained are the methodologies where you will be incorporating that mathematical model to achieve this proposed whatever recommendation or suggestion. Okay, so what is the innovativeness in this title? Because see, you have taken a case study for this subject, no doubt, but there should be something new which you are trying to propose, because I think reinforcement learning is one of the advanced machine learning topics and there is a lot of scope. So whatever is existing, you try to learn the framework, but you try to modify just a little drop in the ocean can make a difference. So what can be innovativeness in Apoorva's topic? That emotion awareness. Okay, so instead of static playlist, recommendations adapt dynamically based on real time. That's why instead of supervised learning, okay, we are going towards reinforcement learning. Are you getting that point? So the present system, music recommendation system, is using machine learning, no doubt. That's why you get recommendations, right? But those recommendations are using supervised learning, whereas we are trying to make it one more ahead, okay, more real time emotion detection. So it will be reinforcement learning. RL based adaptation. So, as discussed in the previous video, we are going to use the contextual. Okay, because context is what today there is a lot of still work to be done in the field of AI if context based learning is there. Because there's a lot of things where, market is growing, data is growing, people's expectation is growing. Okay, people want more and more precise data. When you want more and more precise data, you have to more and more understand the context behind it. Fine. So context is that today you have a very good playlist, right? But sometimes you're not even in a mood to see your own playlist. I do not know why. It happens with everybody. So what is the current context? That will be very, very crucial role to play to enhance your mood. Okay, so for that recommendation system also, you will have to incorporate that contextual back. Then some quick short-term adaptation. Some quick and some long. Why? Because suddenly your mood should change. So you should not give a recommendation after half an hour where already you have bursted out to somebody in aggression. So immediately, if that gives a recommendation, a fight can be avoided. So some short term and of course some long term. Why long term? Because every time you cannot give a recommendation to change the mood. Sometimes you need to have a pattern for a person to improvise in their even habitual behaviors. Okay, so this is how the innovativeness in this proposal can be done. So this was my recommendation on your proposal, Apoorva. Good work done. Okay, so any questions on this? Otherwise, we'll end this session. Okay, so thank you.
No, ma'am.
Yes, thank you very much for your patience listening. This is Aisha Butalia signing off this session with Apoorva on her case study.